All right, this is lesson 10.3, experimental probability. Here's the deal. If I asked you the probability of rolling a dice, of rolling a single, a number cube, they call it, and so what's the probability of rolling a 4? You all know the answer to that, right? What's the answer of probability of me rolling a 4? 1 out of 6. It's pretty straightforward, right? There's 1 yay and 6 ways, right? Yay is over ways. Remember that? Yays over ways. How do we know that the probability is 1 out of 6, though? We know because... Is it not working? Oh, I see it. I got it. Let me pause this. So how can we know that it's 1 out of 6? Well, because there are 6. We know there's 6 ways, and there's only 1 yay. We know that, right? Well, what if I was to ask you guys, okay, what is the probability of us going outside right now and standing on Buena Vista Avenue, on the sidewalk on Buena Vista Avenue, and saying and seeing, what's the probability of the next car coming by being white? But is the probability 1 out of 26? No. Probably not. No matter what you say, aren't you just taking a guess? Right? Aren't we just kind of like, just kind of throwing a stab out there, 1 out of 5, 1 out of 20, 1 out of 10, whatever. We're just kind of throwing a number. What would we have to do? What would we have to know in order for us to know the real probability of the next car coming across the street being white? What would we need to know? What would we need to know? No, don't say the average. What would we need to know, Jonathan? What is the number of ways? Meaning what? The number of cars total. I mean, like ever been made, right? Wouldn't we need to know the total number of cars that's ever been made? Or at least know the total number of cars in the entire city of Walnut Creek, right? And then wouldn't we need to know how many white, so this is the number of cars in Walnut Creek, and that would be the number of white cars in Walnut Creek, right? Or the number of cars made, because sometimes to people from Concord, is it possible that somebody from Concord could be on Buena Vista? Is it possible that somebody from New York City is on Buena Vista? Yeah. So then all of a sudden you're like, oh my goodness, so do you think that there's actually any real way for us to know this information exactly? How many total cars have ever been made and then the total number of white cars? I don't think so. I really don't think so. So this is a situation where we need to do, ready? We need to do what's called an experiment. Much like a science experiment, we need to go do a regular experiment. We need to go and do a math experiment to go see what the probability is. Now here's the deal. Since we actually have no idea, we have no idea what's the probability of it being a white car, what we need to do is go out there onto Buena Vista and watch. And watch, say, 20 cars come by. And the first car that comes by, we see, okay, the first car is a blue truck, right? But it's blue, right? Boom. So there's, actually, all we care about is this, total and white. Do we care that it's blue? No. So then all of a sudden, the first car was, we won't do total. We'll call it non-white, right? We'll say non-white. First one's a non-white. The next car comes by, oh my goodness, it was a white car. Next one comes by, it's a red car. Next one comes by, it's a purple motorcycle. The next one comes by, it's a green Volkswagen Bug. The next one comes by, oh my goodness, it's a white pickup truck. The next one, you see what I'm talking about? Here's the deal. At the end, when we do this, let's say we go out there and watch 10 vehicles come by. And it turns out that 8 of them were non-white. I better draw that clear. Non-white was 8, and the whites were 2. Knowing this, and this is the only information we have now, because everything else is just a guess, what would you say is the probability of the next car being white? What would you say, Sladen? What would you say? What would you say? Based on our experiment here, what would you say? It isn't 1 over 4. It isn't 1 out of 4. It'd be 1 out of 10. Sorry, 2 out of 10. 1 out of 5. Because look, how many total cars have we got there and see? 10. The total number of ways that we went out in there and was 10. How many were yays? 2. 2 were yays. We're looking for white, right? 2 were yays. 2 out of 10, 1 out of 5. Does that make sense? Does that make sense? Yes. Is that accurate? Do you think it really is 2 out of 10? I don't know. Probably, it might be close, but what would we need to do to be even more accurate? What would we need to do? We just pretended that we went out there and saw 10. What would we need to do to be even more accurate?
More tries.
Do more tries, right? Do 100, right? Watch 100 cars come by. Oh, and after we do 100, it ends up being that, let's say that we went out there and watched 100 of them, and it ended up being that there were 84 non-whites, right? And then 16 whites, okay? After we've done that, according to our experiment, or the question would say, according to the experimental probability, what is the probability that the next car that comes by would be white?
4/25.
Wow. Yeah, it's 16 over 100, which reduces to 4 out of 25. Does that make sense? That would be the probability. Make sense? Does it make sense what I'm saying? Does it make sense? We don't know the probability, and in a situation like this, here's the deal. What if I told you that a student was going to, the next student to walk through the door, I was going to ask what their favorite color was. And the options were, red, blue, or green, okay? And I said, okay, what's the probability that the next student that came in here, that their favorite color would be red? How would is it really? Do I know? How many people here, of these, which one do you think is the least likely the most favorite color of people? Green, right? Why? Because it just is, right? We know that. So then is it really 1 out of 3 that they came out here? What if I said this? Red, blue, or dark brown? Right? Now listen, is dark brown possibly the favorite color of somebody in the world? Sure. Yeah, I'm sure it is. But do we know the exact probability? No, right? So my point is that what do you think we need to do? What do you think we need to do to help us figure out what is the probability that the next person that comes in here, the next student that walks in here, that their favorite color would be red? What should I do, Sladen? Right. Let's do this right now. Let's see right now. Choose one right now in your head. Okay? So there's red, blue, and green. Choose one of those 3 right now, quick, as I come to you. Blue, blue, blue. Okay, so here's the deal. Here it is. Add them up. Oh, mine, red. So here's the deal. There's 5, 10, 14 total. 14 total colors. 14 total people chose colors, right? How many of them chose red? 5. So then the probability of, the experimental probability of the next person coming in here choosing red would be 5 out of 14. Does that make sense? Which, if you were to make that a 1 out of something, that's close to, 5 out of 14 is very close to 1 out of 3. It is 1 out of 3, right? 5 over 15 would be 1 out of 3, so 5 over 14 is going to be very close to 1 out of 3. Does that make sense? We don't know that that's true, but it certainly, we've now done something to help us with this, to figure out the probability. Does that make sense? What about this? What if, well, let's go do this. We'll do something. We'll go outside. So we went outside and we watched 14 vehicles go by in 3 minutes. Of the 14, 0 were pickups. No, none was a pickup. One was a weird truck, but it wasn't a pickup truck. Now, here's the deal. The reason why experimental probability is not very good is because if you looked at this, you would say that it is impossible for a pickup truck to be going by. We know that's not true, right? I mean, Mr. G, he drove up in a pickup truck. It's his truck's out there. So experimental probability is not great. What happens if there was a gardening convention down the street down there, right? And you had all these people that came by with these pickups, and like 12 of the 14 trucks were pickups that came by right when we happened to go out there. We'd be like, wow, it's almost guaranteed that we're going to have a pickup be out there. Does that make sense? So experimental probability is not great. But you use it when you don't have any other choice. You use it when you don't have concrete information. Concrete information being like a number cube. We know there's 6 numbers on here, and we know exactly what the ways are and the A's. When we go out there and go, well, what's the probability of it being a pickup truck? I don't know. You might take a guess, but you don't know. So you have to use an experiment. You do. Now, what should we do if we really wanted to be pretty accurate as to what the probability is? We'd stay out there all day long. All day long, we'd be out there and we would count the 2,000 cars or trucks that go by, and we would see. That's what we would do. And even then, is that super accurate?
No.
No. Maybe today, the people that normally drive a pickup didn't. Or maybe today, people drove more pickups than normal. You don't know, right? But you use what you have. Would it be a fair or a reasonable thing? If I wanted to know what was the probability of, if I wanted to know this, what's the probability that people buy a minivan as their vehicle? Would it be a very smart place to look in a school parking lot?
No. Yeah. Yeah.
Why wouldn't it be a very smart place to do this yays and ways in a school parking lot? Why wouldn't it be a good idea, Sladen?
And taking their kids to school, you probably would have taken.
Most people that are on the road that are taking their kids to school are more likely to have what? A minivan, right? I mean, isn't a minivan kind of like a commuter, for kid transportation, mode of transportation? Just like if I was to go to Beverly Hills. You guys know where Beverly Hills is?
Yeah.
Beverly Hills is a very wealthy place. I mean, like the average house is like $3 million down in Southern California, right? And I was to say, okay, what's the probability of people owning a Ford pickup truck? And I was to go into Beverly Hills and see how many of those people probably own a Ford pickup truck. None, right? Maybe one, but he's hiding it in the back or something. You know what I mean? Like,
Beverly Hills does.
probably not very many Ford pickups in Beverly Hills. So that's why my point is that experimental probability is a very inexact science. It is very loose, and you only want to use it when you just don't have any information at your disposal, right? Anyway, the where or how you ask. See, now you start talking about taking surveys. If I was to do that, what if I was to weight the color thing and I was to let them walk in the room? And what if I really wanted them to pick green? Okay, what if I somehow, for whatever reason, I wanted them to pick green? And I was to ask them the question in this way. Hey, Hannah, we'll use my daughter. Hey, Hannah, what's your favorite color between ugly red, disgusting blue, and awesome green? You see what I'm saying? Or if I was to say, what's your favorite, food? And I really want her to say jambalaya. And I go, what's your favorite food? The disgusting, greasy pizza. Or, big, huge, heart attack causing hot dogs. Or delicious, healthy jambalaya. That's your 3 choices, but you see how me asking the question would certainly, it may not bother her, but you could see where the way I ask the question would certainly affect some people. Does that make sense? So again, that's what I'm saying is that it's experimental probability is not an exact science. I am not going to have you guys do any of this homework. It is what I mostly want you to understand is how experimental probability works. One thing that they actually ask you to do is they want you to take a dice, and they want you to roll it and see how many times a 1 comes up, a 2 comes up, a 3 comes up, a 4 comes up, 5 comes up, a 6 comes up. After I roll it 6 times, is it guaranteed that I'm going to have a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6? In fact, wouldn't that be pretty amazing if that was true? Yes. Isn't that weird? And yet the probability says it's supposed to, and yet if it did come up that way, we would all be like, weird. Right? That would be really weird. So, you roll it 60 times and see, so if I rolled it 60 times, let's see how many we can do this. If I rolled this dice 60 times, how many times should it come up 1? 2. If I rolled it 60 times, how many times should it come up 1? 10. Right? 1/6 of the time. Right? So if I did it 60 times, if it didn't make it 10 exactly, would that mean that something's wrong with the die? No. We're dealing with probability. We're dealing with odds. We're dealing with chance. Right? It's not an exact science. What is an exact science is as long as this dice is proportional and it has been made and manufactured properly, then it should come up 1 out of 6 times. Does that make sense? You guys ever heard of weighted dice before? People that cheat? Weighted dice is when they put a little, they'll cut a little, inside one of the holes, they'll put some lead so that it's heavy on one end of the dice inside, you can't see it, so that when it comes up, if I want it to come up a 1, they'll put a bunch of heavy stuff in the dice right above the 6, so that when it rolls, it always, the heavy part wants to go down to the ground. Does that make sense? And it always comes up a 1. Does that make sense? You know what I mean? That's a cheater thing, but that's what I'm saying, though, is that this dice needs to be weighted properly. Otherwise, it's not a real random chance. If I somehow was to take my knife and just take a hunk off the corner of one of these things, now would this be a real, would we know the exact probability of things if I took a hunk off this? Does that make sense? Probability is all, it's not, it is an exact science, and yet it is not. Right? Even the very fact that there is 3 holes taken out of the 6 and only 1 hole taken out of the 1, do you think that the weight difference would make some difference as to how often the 1 came up as opposed to the 6? Just a little bit, but a little bit nonetheless. Anyway. All right, you're lucky. I think this may be the first time all year that I haven't given you any homework. Is that true?
No.
Wow. Once other? Wow. Crazy. All right, so we're going to lose no